Okay.
Okay, go for it.
So tell me about your background.
Background. So I grew up on a small farm in western Pennsylvania that had been in the family 100 years. So I grew up driving tractors, forking manure, all that good stuff. Went off to school at Penn State, thought I was going to be a physicist until I got captured by computing, which turned out to be a fine choice. I ended up doing a master's and PhD in that and got recruited to go to Bell Labs. And that was 1973. Spent 10 years at Bell Labs doing Unix software, managing projects, worrying about programming environments, software methodology, all those sorts of things. I then decided I wanted to be in California. I moved out here, worked for Convergent Technologies, an early workstation company, in 1983-84. Got recruited to go to MIPS Computer Systems to build new RISC microprocessors. Did that, managed operating systems, helped found the SPEC benchmarking consortium to make better benchmarks that were more realistic. In 1992, we got purchased by Silicon Graphics, where I was various things, typically later chief scientist and vice president. I was one of the architects of the big supercomputer systems that SGI did. I helped design microprocessors. I did software strategy, and I spent half the time talking to customers. So that's kind of my background.
I'll zoom in a little bit just one sec. Okay. What was your involvement with the develops of the Unix operating project?
So I started in 1973, a few years after Ken Thompson and Dennis Ritchie had written Unix. So I'm not one of the very first people. I'm pretty early. When I started, there were 20 Unix machines in the world, mostly used by individual researchers or small groups in labs. What I did was join a project called the Programmer's Workbench version of Unix, which was trying to make it a general purpose utility that many people could share to help automate the work of programming. So what we did is sort of take Unix out of the lab, put it into the computer center where lots more people could use it. So I did things like converting the Unix command interpreter into more of a programming language so that people could automate their work, because we had a lot of it to do. I was involved in converting the converting the Bell Labs typing pools into Unix-based word processing rather than typewriters. That was a fairly large-scale effort. So I, at one point, moved to the Unix support group where we were trying to consolidate versions of Unix. And then the last 5 years, I was managing Unix-based applications projects, data mining projects used for managing telephone repair, of all things. So, I spent about 10 years there as an individual contributor or a manager. I wrote some fairly frequently quoted papers and spent a lot of time trying to explain to people about the philosophy of Unix and the tools approach that Unix was pioneering.
How has Unix changed the world of computing?
That's hard to say in a small time because it's so immense. Unix has had a couple very strong influences. The first was that it was made to be a portable operating system that would run on different kinds of hardware. That was very rare in the 1970s, right? But as a result, it created a lot of good software that could be moved around, and in particular, it was crucial to the new microprocessor-based systems that were appearing in the early 1980s, because you could port Unix over to something new without having to create a whole operating system from scratch. When we were doing the MIPS RISC chips, we never could have done that if we'd have to create an operating system from scratch. So that's the first thing. The second thing is that it had a huge influence on technical computing, great deal of use of Unix workstations and servers. Most supercomputers run some version of Unix and have for quite a while. The third thing is that the networking, the big increase in networking, was strongly influenced by the version of Unix done at the University of California at Berkeley, basically under some government contracts. This got the TCP/IP protocols out there in wide use and led to a huge expansion in internetworking of computers. Now, of course, by now, Unix, there's some version of Unix in your cell phones. Android is a derivative of Unix, so is the iOS that's in Apple's, right? And some of the software that started with Unix, like the C programming language, is just used in a huge number of products that you may never see, but it's there. I guess the next thing is the things behind the scenes, where people use computers to design other products, or they run services behind your back that you don't see. A huge number of those are either on Unix or use software that started there. So Unix has had a very large and pervasive influence, even though you may not ever actually log into a Unix machine directly and use it yourself. It is all over the place in science, engineering, and business.
What would be missing today if not for Unix? I've heard that the game Space Travel helped to boost the development of Unix.
Yeah, actually, Space Travel was, I think, the first application that Ken Thompson wrote on a very early Unix. But I think that's fairly minor. Of course, people play games on Unix. Ken Thompson, for many years, had the World Computer Chess Champion program called Bell, B-E-L-L-E, all right? Funny, sort of, given the reason the Bell system. I think a lot of things would have happened without Unix, but what Unix has done is provide a huge amount of productivity for people. There are just many applications that just wouldn't expect to be there if something like Unix had not been developed. The oddity of Unix, of course, is that it was developed not at a computer manufacturer, but at a place like Bell Labs that was not in the business of making computers. That is somewhat of the key to how portable it got and how pervasive it and its toolkits became. And those toolkits are underneath an awful lot of the software that is currently built. The scripting languages we developed in the 1970s are in some sense ancestors of the languages that people use to build internet applications today.
Did you also help develop the C programming language?
I didn't help develop it, but I certainly was an early user of it and commenter. If you get the Kernighan and Ritchie C book, the original one, you will find me acknowledged for comments and input to things. That early C language was really Dennis Ritchie. I mean, that's who was it, right? I did do some of the work later on when C got converted to 64 bits and how to handle that properly. I did do some work that ends up being in the C reference standard. So I have a little bit of influence there, but that's Dennis Ritchie.
Yeah. How has... One sec. How has Apple, in a sense, developed the Unix system into Mac OS, and how, in a way, is it they're kind of marketing it for consumers, whereas most Unix and Linux systems are being used by professionals?
Yeah, so that happened sort of in an odd way in that Steve Jobs was off doing Next Computer for a while. In fact, he hired one of my best systems programmers to manage some of that work. And that was a pretty good version of Unix, And when he came back to Apple, that was acquired in there and ended up over time becoming the basis for the operating system, which was a wonderful thing because as brilliant as the original Mac OS was, it had gotten, let us say, long in the tooth by the mid-90s. And so Unix sort of was separate, but it came back into the fold. It's a good example, though. Unix is under an awful lot of things that where you would never realize it was there, and that's a perfect example, whether it's iOS on iPhones or Android on other smartphones. It's in quite a few things. And indeed, you know, the average user doesn't have to know there's a Unix anywhere near that.
Discuss the Unix wars and Plan 9 from Bell Labs.
Okay. Oh, great. So one of the things that happens, because Unix was fairly open from the beginning, is it tended to spawn multiple variations. And there were fights over all different combinations of Unix, everyone touting them to be better. I think actually this was a good thing, even though it was chaotic, because it let different people make contributions. For a while there was a supposed fight between AT&T's Unix and Berkeley Unix. There were fights between other combinations. What's tended to happen is it's sort of like survival of the fittest. Good genes get bred back into the overall species, and so it made quite a bit of progress. Plan 9 was a research version of a whole new operating system done at Bell Labs much later. Its name comes from Plan. What was funny was in the 1970s, the computer centers all had big mainframes, and they'd been growing like this, right? And then they started to flatten out, and we're trying to figure out what happened to the growth, right? It turned out that a Bell Labs director could spend about $250,000 without having to bother anybody, right? Okay. And that was enough to buy a PDP 1170, a couple disk drives, a couple tape drives, and printers and stuff like that, right? And they all said, I'm tired of messing with the computer center, I'll just go buy this. Well, that worked for a while. What happened then was that people discovered administering computer systems is time consuming and costs people money. And they ended up moving them back into the computer centers. The computer center said, look, you buy what you want, but we'll manage it for you. Right? And it's just sort of like when everyone ran off and got different PCs and Macs and stuff, and because they each could do that, but the trouble was the networking was crazy, and the sort of networking support moved back into the central IT organization. It happens again and again.
SGI uses IRIX, which is a Unix-based operating system. Did you help implement this into SGI?
I did. Let's see. When I was at MIPS, our first main customer was SGI, and I worked with the Unix guys over there. One or two had actually worked for me before at Convergent Technologies. It's a small world in the Valley, right? And I particularly worked with them on the multiprocessor features. Now, as it happens, when I was at MIPS, the very first port of IRIX to MIPS chips, I actually managed running a team that was half MIPS and half SGI. Right? So the first Unix System 5 IRIX port was something I ran. So, yep, goes way back. That was around 1986.
And tell me about the MIPS chips as well, like how you helped develop that and how that has influenced.
Yeah, so MIPS chips. So I was a director of software at Convergent Technologies. John Hennessy, currently president of Stanford, and his other co-founders came over to present to Convergent. I had a lot of comments about them saying, hey, I've always loved RISC chips. I love the idea of simplicity and just having the features that we need and chips that work well with the C language. I like all that. I said, but I know you had chip people and compiler people, but you didn't have any operating system people, did you? And they said, yeah, you're right. How did you know? And I said, your first chip has features that no operating system person ever asked for, right? So they went, oh, okay. But I said, well, actually, that was the Stanford version. We're doing something a little different. Gee, well, maybe you want to look at the real specifications. And I ended up being over at MIPS every Saturday looking at things. And they started saying, you know, you're here a lot. Why don't you come work here? And I said no for a while, but then I couldn't resist, because the once-in-a-lifetime chance to help create an architecture that actually was what I wanted in terms of software was just irresistible. And so I moved over there by early 1985. I managed the operating systems group, networking, software quality assurance, and also did a lot of work on the architecture of MIPS chips in terms of the issues that operating systems cared about. And I also worried about using MIPS in embedded control applications and got some features in for that. I was involved in the design of the 64-bit versions. And so I usually worried about the hardware-software interface and how those things fit together. You know, so I was involved in design of many MIPS chips. I also spent a lot of time helping our semiconductor partners sell them to key customers. Like, I got pulled in to help sell a small networking company on the idea that 64-bit MIPS chips were a good long-term investment. And they made that commitment around 1991 or 1992 for use in their routers. Turns out that small company's name wasn't Cisco. Right? So as a result, there are MIPS chips everywhere in the internet. And actually they're in a lot of other things as well, in terms of laser printers and cameras and other internet gear. So that's the involvement there.
For 8 consecutive years, 1995 to 2002, all films nominated for an Academy Award for Distinction, Achievement in Visual Effects were created on Silicon Graphics computer systems. How did it change the film industry forever?
Yes, it did.
Yeah.
So, yes, I used to work with folks from Industrial Light and Magic, Digital Domain, Pixar, Sony ImageWorks, and of course Weta Digital, where Lord of the Rings was done. So I used to help plan some of the systems for those folks and tell them where technology was going. Indeed, SGI's work on this changed the film industry forever. If you look at the history of computer graphics in film, some of the earliest stuff was done to make jazzy science fiction-y looking effects. That is, flashing things and, you know, things that didn't look real at all. Later, they started to make things that looked real that couldn't be real, but they looked real, like dinosaurs in Jurassic Park. We know there aren't dinosaurs running around, but they sure look pretty good, right? Later on, they got to make more things that not only look real, but could be real. There were a lot of crowd scenes that were done. For instance, in Clint Eastwood's In the Line of Fire movie from years ago, where a lot of the crowd scenes around presidential candidates and so forth weren't really there, they just replicated the people, right? We got things like, in Titanic or other movies about that time, where they finally got waves to look realistic, and waves are a lot cheaper to do in computers. Yes. So clearly the video game industry has come a long way from Pong. And in fact, this is one of the ways that technology progresses. At first, it may be something that costs hundreds of thousands of dollars to get something that's slightly realistic looking 3D. By now, we have 3D graphics chips sitting in smartphones, right, that are far more powerful than those early SGI machines. But indeed, there was a tight relationship between some of the movie making, the video games, and the various special effects that people got into. That was all part of the same thing, sometimes with the same people.
Okay.
So I was born in 1946, right about the time of the very first digital computers. When I was growing up, computers were huge, expensive mainframes that very few people had access to. I was lucky enough to get into computing just about the time it broadened out with mini computers and less expensive devices. I was really lucky to be at Bell Labs, a tremendous R&D organization. Very lucky to get into Unix right when it was started. Lucky.
You can continue.
Okay. And lucky to get the chance to build a lot of hardware and software that have done a lot of interesting things for the world. Made safer cars, help people find drugs, help people do new science. And that's been a lot of fun, and I don't think this business is done yet. We still have a long ways to go. But probably one of the most interesting things about this is how much people now take for granted. This stuff wasn't here 50 years ago, but it is now.
Okay. Perfect.
Okay.